Well, here's where we left off with our free body diagram of the cart. And the question we were left asking is, how can we find the net force on this cart? How can we find net force? That's something new, something we haven't seen before. So let's find out. So what is this idea of net force? Well, we know from our fact sheet that net force is going to tell us if the forces acting on an object are balanced or unbalanced in a certain direction. And what that means is we can think about an object like a free body diagram, and maybe there's some force or forces pulling on it to the right. You know, all the right forces. And there might be some pulling to the left. All the left forces. There could be one, there could be two, there could be several, or there could be zero. Same is true in the up direction. There are some sort of up forces, and then in the down direction, maybe there's one, two, or more down forces. And so what net force is trying to tell us about is, are these forces balanced in their different directions? Are they balanced in the left-right direction, the horizontal, and are they balanced in the up-down direction, the vertical? So the way we find that out is we're going to write two equations. One equation in the vertical direction, that is up and down, and one equation in the horizontal direction. I'll abbreviate it here, horizontal, and that is left and right, horizontal. And when we look at our fact sheet, we know that all we need to do to find the net force is write this equation. So start out and say F net. That only means net force. F net is equal to the up forces minus the down forces. So all of the up forces, all the forces pushing or pulling up, minus all the down forces, all the ones pushing or pulling down. So let's fill that in. So then we know F net is equal to, well, what are our up forces? What's that up force? FU. Oh, can't say that in mixed company. Minus our down force, which is FD. That's all, represents all of our down forces. Now it could be multiple. If there were multiple down forces, if there was another down force, let's say FD2, well then we would also subtract FD2, if that was true. But let's say that that's not. We don't need that. Okay, so there we go. So that now all we need to do is subtract those, and it gives us our net force. Now let's do the same thing for the horizontal forces. So F net equals, we know on our fact sheet, it is all the left forces minus all the right forces. So all our forces pulling or pushing this way minus the ones pulling or pushing this way. Well, from our little diagram, our pretend example here, we know that the left forces are FL minus the right forces, which are FR. And that gives us our net force. So this might be a little confusing because we don't have any numbers here. So let's look at our example of our fan pushing on our cart, and let's see if we can apply this. So here you can see I brought in our free body diagram from before. This was our fan cart. I didn't include the list of forces. They're the same. But let's see if we can figure out how to find the net force. And what I'll do is I'll take those equations from the last page and I'll bring them over here, those equations for net force that come from our fact sheet. All right, here they are. So now we've got two equations to find net force in the vertical direction and in the horizontal direction, which is telling us again if the forces are balanced or unbalanced in either of those directions. Let's start with the horizontal because that one's going to be easier for us to do. So we know that the horizontal net force, all we do is we take all the left forces and we subtract all the right forces. Well, what are our left forces? Our left forces are the force of the fan. And what are our right forces? What are the right forces? There are no right forces. There's nothing. So in this example, it is minus nothing, 0 forces. Or you could say minus 0, if that makes sense. If you subtract 0, you subtract nothing. There's nothing there that we care about. Awesome. So what did we just find out? We found out that our net force is equal to the force of the fan. And how many newtons do we know is the force of the fan? Well, we know the force of the fan is 2 newtons. And in what direction? 2 newtons to the left or to the right? Well, the fan's pushing to the left. So our net force is 2 newtons to the left. So that's how we would write it. We've got a number and a direction. So there you go. Our net force is 2 newtons to the left. That's it. Left forces minus right forces equals the net force. Net force in the horizontal direction, is 2 newtons to the left. So now let's look at our vertical direction. So all we need to do to find net force in the vertical direction is to take all the up forces and subtract all the down forces. All the up arrows minus all the down arrows. And what are our up forces? This is our fan, remember? So our cart with the fan on it. So what was the up force? It was the force of the table pushing up on the cart. As I have a highlighter, there we go. Force of the table, that's better, on the cart, minus the down forces. Do we have any down forces? Yes. We have the force of the earth, or the force of gravity from the earth pulling down on the cart. So there we go. F net is equal to Ft minus Fe. So here's our cart. I've recorded it for us, and what I want you to do is I want you to watch this video. So here it is playing, and let's draw our forces that we had from before. So we had the force of the fan pushing to the left. We knew that was 2 newtons. Down, we had the force of the earth, which was 5 newtons. And then up, we had the force of the table, which we didn't know. That was unknown. Now what I want you to do is I'm going to play this again. I want you to watch something specifically about the cart's movement. Is the cart moving in only the horizontal direction, as in only left or right, or only in the vertical direction, meaning only up or only down, or is it moving in some combination, as in up and to the left or down and to the right? So I'm going to play it and watch. And here it is again. Well, you know, it's moving on the table. So it's only moving to the left in the horizontal direction. Only to the left horizontal. It is not moving up or down at all. It's not going above the table, below the table in any way. It is only moving in that direction. So what does that tell us? It tells us that even though the forces are unbalanced in the horizontal, yes, they're unbalanced in the left and the right, because the cart's not moving up and it's not moving down, it's staying in the same place vertically. Because of that, we know that in the vertical direction, the net force equals 0. F net equals 0 in the vertical direction because the cart is not moving up or down. It is only moving left and right. Because it's not moving up or down, F net is 0 in the vertical direction. So let's take that and let's go back to our equations. Okay, so what did we just find out? We just found out that in the vertical direction, our net force is equal to 0. F net equals 0, which means that Ft minus Fe equals 0, and that Ft minus 5 newtons equals 0. Remember, we substituted those 5 newtons in because we know the weight of the cart is 5 newtons. We just plug that in. So now we've got an equation we can solve. We know Ft minus 5 newtons equals 0. So solve for Ft. Ft equals 0 plus 5 newtons, which equals what? 5 newtons. You're smart, look at that. 5 newtons. So what we found out is that Ft equals 5 newtons. So let's write that out. Ft equals 5 newtons. This is something we figured out. Ft equals 5 newtons, and I'm going to draw it on our diagram here. Just add it in there, 5 newtons. And why do we know that? Because the cart is not moving up or down. It's not moving up or down. It's only moving left and right. So net force in the up-down is 0, which means Ft is equal to Fe. They balance out. So let's summarize what we found out. We have two different things going on here. In the vertical direction, we know that F net equals 0. And so what we found out was that Fe equals Ft equals 5 newtons. Both those are equal to 5 newtons. They balance out. Forces are balanced. There we go. Now what about in the horizontal direction? Well, in the horizontal direction, we know that F net equals 2 newtons to the what direction? Left. We know that F net is 2 newtons to the left. And so in this case, the forces are not balanced. They are unbalanced. They're in the horizontal direction. And that's okay. It's okay for the forces to be balanced in the vertical and unbalanced in the horizontal. That happens all the time. Sometimes they're only balanced in the horizontal and not in the vertical. Or we'll see some cases where they're balanced in all directions. And that means the object is totally in equilibrium, which we'll talk about later. But there you go. All you need to do to find net force is to figure out from your equation left forces minus right forces. And then for the horizontal, that's for the horizontal. And then for the vertical, up forces minus down forces. F net is just the difference in the forces in the vertical. And then in the horizontal, it's the difference in the forces. So why don't you see if you can take that and tackle some of our missions that I've got laid out for you. Thanks.